I'll begin this afternoon session with a brief introduction. Welcome to the Canadian Institute of Forestry's National Electronic Lecture Program. My name is Sharon Young, and I will be hosting today's session. Today is Tuesday, April 1st, 2025, and this is a nice session in the e-lecture series entitled Advances in Operational Forestry, Tree Planting, and Carbon Mitigation Research. The series is a collaborative effort coordinated between the Canadian Forest Service and the Canadian Council of Forest Ministers. The CIF-IFC is very pleased to collaborate and host these webinars. For today's session, we are pleased to have Jean-Martin Lutin, who will give an exciting presentation titled Advances in Research Towards the Digitalization of the Forest Sector Value Chain. To kick things off, Jean-Martin has been a forest engineer and research scientist in silviculture at the Canadian Forest Service since 1998. He earned a Bachelor of Science in Agriculture in 1988 from Laval University, a Master of Science from the University of Quebec at Chicoutimi, and a Ph.D. from the University of Quebec at Montreal. He is a member of the Canadian Wood Fibre Centre, a research center of Natural Resources Canada, whose work aims to improve the competitiveness of the Canadian forest sector. Over the last 20 years, his research work was centered on the silviculture of partial cutting and more recently on the digitalization of the forestry sector for the optimization of timber and bioenergy supply. With that, I will now pass it over to Jean-Martin.
Thank you, Sharon. You can hear me?
Yeah, I can hear you
perfect.
well.
Okay. I'll try to make it exciting, like you suggest. So, the purpose of my talk is to give you an update on our research program that we started 4 years ago. I made a presentation at the same place, CIF, a year ago. So I'll try to give you a sense of the things moving on. So let's start with, give me a second just to get a control. Okay. So brief introduction about digitalization, what is it, what it is, and what for. So here we can visualize the schematic view of a forest value chain with different business units. And traditionally, we're presenting a value chain by the flow of matter between the business units from the forest down to the market. Also, you can visualize the exchanges of energy between the business units. Some are energy producers, others are consumers. But what we're interested in is the flux of information between the business units and within the business units. There's a lot of data that is flowing, and we underutilize these data currently for improving business processes and efficiency. So give the example of harvester data. So single head harvesters are producing and consuming a lot of data, and this data can be used for different applications. So first, for harvest operation dashboards, understanding what's the current production of the cutting machines. What is the the fuel consumption, for instance? So these dashboards inform on the current situation. Next step is that we can use this data for making forecasts. So using AI models to make prediction on harvest yields and productivity and support planning, operational planning with enhanced predictions. And finally, we could use this data for automated work schedules when using optimization to help us on scheduling. These are example of what's understood as being the digital intelligence. So digital intelligence is using data for understanding, predict, and decide. And you can see different technologies, business intelligence, machine learning, and operational research as the tools that are used. Digitalization also encompasses the automation or robots, but we're not at the Canadian Forest Service and CanMet. We're not involved in these fields. We're really focusing on digital intelligence. So making most of all the data we're collecting at different stages of the workflow. give you an example of, in particular, what does it mean? Well, we've got the forest value chain that is producing a lot of data, LiDAR, GIS, weather, sensors, also data, economic data, the data from the machines, data from the people. And we need to centralize this data, organize this data in a way that can be used. So data integration and fusion into data cubes, metrics, data products. And then using this, we can leverage and produce what we call digital twins. So digital twins is it's just a digital reproduction of reality. So it's can be either models or representation of the what's going on in the mills or in the different business units. So to understand, forecast, and decide with like dashboards, cause and effect analysis, data mining, etc. And the application for industry, well, asset management, diagnostic prescriptive maintenance, that's one application. The other one is supervision of control systems. The other one is operations to planning and scheduling, and finally the design of processes and products. So these are the thing we can produce with these digital twins. Why do we need that? Well, they're challenged right now: labor shortages, uncertainty in supply, lack of agility, and increasing environmental and market constraints. And the benefit of the digitalization potential is reduced workload for individuals, better visibility of operations, timely forecasts, better and faster decisions, and better coordination. Um, the digitalization transition is ongoing in most of the manufacturing industries, and the forestry sector, unfortunately, well, the transformation sector is on board, but the forest operation, what's in the forest, is critically lagging on that transformation. So we started 4 years ago, 4 years ago, a research initiative that is quite original because it's bringing two research teams for NRCan. So first one is the Canadian Wood and Fibre Center from Canadian Forest Service, and the other one is CanMet Energy, which is a sister organization within NRCan. And CanMet Energy, they're accustomed to work in mills and mostly on energy efficiency, and they've got a great expertise on machine learning, artificial intelligence, and analytics, and they've been involved into improving processes in lumber mill and paper mills. And on our side, Fibre Center, we're good at wood production. So working together is a great opportunity to work on the fiber on the forest value chain as a whole. So that's the team. The solution we're working on is data analytics, forecast, and optimization. We've got partners with industry, government, suppliers, academia, innovation, and you can see here what are our priorities. So that's an image to give you an idea of our team. So let's start with a few stories about what has been happening for the last year. So first, we started 4 years ago with building a strong partnership with companies and government in New Brunswick to start case studies. And this year we grew by doing the same thing with the Quebec forest sector. So we hold a consultation in June that was completed in June 2024 with these partners, understanding their needs, discussing about priorities, and that brought us to this 5 themes of work: strengthening digitalization skills and capacity, um, valorization of harvester data, optimizing transportation and inventory management, digitalization of biomass management and processing, and finally, digital intelligence laboratory. I'll go more in details later. And also a ninth thing that happened, we signed an agreement with FORAC, which is a research consortium at Laval University that's been going on for the last 20 years, and they're the specialists in Quebec on the research on forest value chain and optimization. So we have a strong common program with FORAC. I'll start with the first story about a research project on timber transportation and optimization and coordination, led by my colleague François Aubé at CanMet. I'll try to not massacre his work. I'm not very familiar, but I'll do my best, François. So, what are the needs for optimization of transportation? Well, we need efficient management of wood transport uh, from the forest to processing plant to minimize costs and GHG emissions, to optimize their use of resources, particularly in the context where drivers are getting more and more rare, harder to find. So we have to be very good on the way we're using them, and also to improve planning and predictability of the planning process, and especially to be able to quickly replan after unforeseen events that is very current in the transportation operations. What you know from according for previous experiences in the world, that optimization of transportation in forest can save up to 10 to 15% of the cost. Um, so it is a major potential saving here, just of if we're able to develop and implement optimization tools to have a better coordination and planning of transportation operations. So Francois is working with Abdelhakim Abdelawi. They're making great progress on the development of, well, first of scoping the problem, and that's been done the year before, and this year they've been working on developing the algorithms. So shortly it will be this phase will be completed, and it will go under a trial phase. So the tool is an operational planning of log truck transportation. This planning the routing and scheduling optimization on an horizon of 7 days. With in this case, it's 110 different trucks with point of origin from the forest and point of destination, which are mills. And the case study here is with a forest company in New Brunswick. So it takes into account the selection of the trucks with their capacity. So in regards to road classification, also do the trucks are self-loading or not. And it has to include, is including time constraints, time windows about in question like queuing, possible track pairing, to reduce the dead time in the processes. So the model is providing individual routes and schedule for each truck, and also a full schedule for the supervisor and mill. So you have a full view of what's going on, but this scheduling is coordinated. And what's the very, I would say, neat feature of Francois' model is it allows for replanning or partial replanning with, if we've got unforeseen events. So you don't have to reschedule everything. It's only have to reschedule part of the problem, but it allows to make the solution feasible, even if we've got stuff that happened but wasn't forecast at the forefront. We're talking about here climatical events, weather events, also for instance truckers that are not available that particular day, and we have to reschedule everything. So that has been an impediment for many past optimization solution. That's something Francois is trying to solve. Another story here is about another project is about precision of harvest data on trees and logs. So last year I told a story about using the data from harvester head to make predictions about the yield on cut blocks. But then we're asking ourselves, well, what's the value? What's the quality of the data we're using? We want to avoid the situation of garbage in, garbage out. So we started this study this year of documenting what's the actual precision of operational data from harvesters. So just recall that harvester head is collecting information every tree and every log that is harvested. So length and diameters at every 10 centimeters. So it is very measure intensive. Volume is calculated using scaling formula or the cumulative volume of 10 centimeter cylinders. So it is particularly this part is very precise. But precision is needed for two purposes. First is for log bucking. So we need precision on length because the specification are built around length. And if we have poor quality measures, well, we have poor quality products there. And the other one is to have accurate volume estimates. Precision is affected. You see on the left hand, you see a harvester head, and you can see the measuring wheel between the two feed rollers. So the diameter is measured by the field rollers or the limbing knives, and the length is measured by a measuring wheel you can see just in the middle of the machine. So precision is affected. It is measured by mechanical and electronic device. So the precision is conditioned by is affected by the condition of the head. So the wear and tear, and so question like keeping your knife sharps and roller tight is crucial to have precise data. So it relates to how the maintenance habits of the operators on the machine. It depends also on pressure settings on the feed roller and the knives, and also the temperature of the trees. So when the trees are freezing or thawing, well, the rollers will penetrate more or less, and you have to readjust things over time depending on the temperature. And of course, all of these makes sense if you have a calibration and data quality control processes. So what we've done is, oh yeah, here is a little image of a text I highly recommend. It's a very accessible text from Skogsforsk, our sister organization in Sweden, and explaining what's all the issues, understanding how things are measured, how the quality is conditioned. So give you a very good understanding of what's going on. Um, Another thing we discovered is while making our research is the biomaterial methodology for data quality control. In Quebec, in particular, F Innovation has been instrumental to developing or trying to develop and make adopt standards for data quality control. And we discovered that Biometria is a business in Sweden who's responsible for the trust about data about scaling and harvester head data. So they're certifying harvester operators so they can be trusted source of data. So the way they do for doing that, well, first they proceed first the machine needs to be calibrated on commissioning, and after repair and part replacement. That's and this is done by the operator with an electronic caliper. You can see a picture here on the left hand. Typically, it requires 15 to 25 logs per species. The number depends on the brand of the machine. And you have to take an account a large range of diameters because you're trying to make the relation between the corrected signal versus diameters and length. So a large range of diameters. I forgot to say also length. Then once the machine is calibrated, you have to make some self-monitoring to make sure that your signal or your measurement are still good and there's no drift or no problems with your measuring system. And with biometry, this is done by measuring one tree per species per day. So the machines processes a tree, and then the operator set it on the ground, the logs on the ground, and taking his caliper, he makes measurements. So it's the M1 measured from the harvester, M2 from the operators, and these data is then sent to an auditor, which is an official from Biometria. And the auditor that received the data on remotely will review every 2 weeks the self-monitoring data which is accumulated over 2 weeks, and will give a statistical report on the quality of the machine. And this is supplement, so the operator have a clear idea of what's going on and to make correction if needed, if you've got a drift or a break damage in your measuring systems. This is supplemented with a field control done by the auditor twice a year, first at the machine commissioning and then twice a year. So in the field, they're making validation. So measuring M1, M2, M3. M3 is the measure from the auditor on 50 diameters and 15 length. And so there's a validation report and some coaching given by the auditor to the operator just to make sure that he's developing good habits and good practices to ensure quality data. And this is the report where you can find this. It is written in Swedish, but there's a lot of platform right now very useful to translate this into decent English. So what we've done is we went into the field and well, yeah, we remeasured. Um, we asked the operator to put logs on the ground, and the operator remeasured the logs. So we had a M1, M2. Here we've got a comparison between the M1, M2, M3. Sorry, so the measurement done by the machine and the measuring done by the auditor. And you can see here that we have, in fact, we work with three auditors, different auditors. The object here is to see what is the variation between auditors and to have an idea what are the how precise is the audit per se. So you can see here the graph. Each tile is one machine in one condition. So we've got 1, 2, 3, 4, 16 of them. Uh, I said 12. It is 16. Sorry. And you see on the y-axis is the error, so the difference between the M1 and M2, and on x-axis is the M3, the real measure. And you can see in the blue line, the blue area is the area of precision, the targeted precision we're looking at. And you can see that in most of the cases, or many cases, we've got a strong bias. So it means that we've got a systematic error um, between that changes in relation to a diameter. So this normally should be fixed with calibration. So at first glance, there's a few machines that needs calibration. You look at the sample N, échantillon N on the bottom here. You see this machine is well calibrated. No issue here, but some like sample A has a serious problem with the calibration. The good news is even if the data is biased, even if you've got a strong bias, it's possible to mathematically correct the data. So here's the same data that is mathematically corrected after fact with formulas. I won't go in details here, but you can see we can fix calibration issues. So the calibration can be mathematically fixed. That's the way things are done when you're calibrating the machines in the field. The thing you cannot correct is the random error, and the random error is related to the wear and tear of the equipment. So this is a work in progress. We'll share the reports within the incoming year. So we're very interesting to take stock on what's the quality of data we have and what's the meaning of this. Another story is improving hardwood bucking with cut-to-length harvesting systems. So this is done in collaboration with colleagues from Laval University, and Caroline Benman is making her Ph.D. Study on this one. So we know that in the east of Canada and in Europe, there's an increasing use of cut-to-length system in hardwood, so harvester and forwarders. And the main reason of that is the shortage of personnel. So because we're lacking person, this system requires less people to operate. The problem is that cut-to-length system were designed for softwoods. We've got issues with measuring wheels. We've got inconsistent length precision with hardwoods that they have some crooks and bends that is causing some problem with these measuring wheels. Also, we've got the current automatic or optimizing bucking algorithm are unapplicable in hardwoods because of their complex tree architecture, thinking about branches, thinking about a tree taper that is not necessarily decreasing as the tree you go up in the tree, and also complex price lists with quality grading. So in hardwoods, it's common to have prices that varies with clear faces and sweep, and I would say the there's order of magnitude between high quality and low quality logs. So the research question is, well, what's the performance of the current bucking with cut to length in hardwoods in New Brunswick? And the second question is, how can we adapt this technology for hardwood? So it's more, the last question is more exploratory, an exploratory question. So present you one result about this study. Here you can see for seven cut blocks and 4 species. We're comparing the actual bucking and the mathematical optimal solution for 7 sites and 4 species. You can is the mathematical bucking has been done with an open source bucking optimizer we've created because available solutions were not functioning with modern computers. Um, or they're embedded into commercial solutions that are not available for research. Bucking optimization here is based only on taper with methods that are classical for typical for softwood. So we're mimicking what's going on in a single grip harvester. And tree shape is reconstructed using log measure. So we don't have a very precise tree shape or taper shape, but no, that's the limitation of the methods. The results, well, you can see that by comparing the number of logs, we have optimization creates more logs for pulp and saw logs. So, and the volume also is affected. So using optimization and with we're assuming precise measurement, we're producing more volume in more logs than at the cut block level than the actual. And what we find also is that we're really underestimating the waste, especially for white birch. There's a lot of waste in the actual that we cannot grasp with the mathematical optimization because we don't have the information about about log quality. So of course it's confirming the we knew already it was limiting methods, but measuring what's the gap, that was the objective of this analysis. Excuse me. Nasty cold. Okay. Another research project we started this year was the mapping of digital solution forest operations. So there's a bunch of people. This project is led by Sébastien Meunier with the collaboration of SD Montaker and Raoul Guillard from two Azadi is working with CanMet and Raoul is a grad student in collaboration with my colleague Mouloud. So the idea here is to gather information on data collection technologies. What is the usage, business processes related to that? What's the data format? What's the data availability? We're focusing on log inventory management and truck fleet management. And the purpose of that is to support development of integrated planning and monitoring systems. So we're reviewing, of course, what's currently in usage by our partners. Here you can see a scaling station for trucks, but also we're looking at technologies that are applied elsewhere, but not necessarily in Canada. So like truck scanning devices using either lidar or images. Also systems like the one on the bottom when you see a car close to a pile of wood. On the top, on the roof, you can see a device that is capturing images. So we have real-time inventory of log piles on the roadside or within the mill yard. Of course, harvester machines are part of these systems. They're collecting data on the inventory of logs. And on the GeoTab, this is a classical device for monitoring or following the vehicles, either trucks, log trucks, or pickups. So understanding what's in that, what's the type of data collecting, how it is available, so we can, in a close future, integrate them in systems for improving, for supporting the digitalization of forest operations. So this project has been made great progress this year, and we're expecting to close this project this year. Last story I want to bring is well, up to now we've been talking mostly about beside the project from Francois, which is decision support. Um, Most of digitalization right now in forestry is focusing on acquiring data, organizing data. So either LiDAR or remote sensing using drones, etc., etc. But little is done on the usage of this data for monitoring and planning. So I've been looking through what's the reality if we go outside forestry, and what are the I would say standard or the concepts that are used in industry, in manufacturing industry. And when you make a search, that's something that's coming pretty often. Is what they call the industrial digitalization pyramid. So this is the let's say organization of system within the mill or within a company. What are the different layers of tools that are used for the digitalization of the enterprise? So on the bottom, you've got sensors and controllers. So these are within the machines or within the machines, you've got sensors collecting data. You've got controllers that are controlling the behavior of the machines. So these are really related to the machines, and the machine operator, are interacting with these machines, these sensors and controllers using what they call a SCADA. So SCADA is supervisory control and data acquisition. See that as a screen where you can control your machine and interact with your machine. On top of that, we've got one SCADA from each machine. So each operator has its own SCADA. Uh, but then you go up higher in the hierarchy, and then you've got a production manager, and he has its own system that is called a MES, or manufacturing execution system. And so this system is coordinating the different SCADAs. So you have an overall view of your production in the mill or in your forest, and then you're planning and controlling your machines or in your employees using this coordination tool called the MES, manufacturing execution system. And on top of that, you've got what is called an ERP, enterprise resource planning. Every company has an ERP. Typically, it is SAP or I don't remember. There's a few companies that are providing these systems, that super systems that are taking account all the services within the company that is not necessarily related to manufacturing. So accounting, clients relationships, uh, tactical goals or tactical planning is done on ERP. So our ERP is not necessarily connected with actual production or actual operations. What does it mean? And when you look at, there are existing commercial solutions that are emerging. So, give you an example: Ramsoft operations, or formerly what was the solution produced by Limsomatics. Now they're merged. These are typically manufacturing execution systems that helps to make the planning and conduct the operation at the for the production managers. Um, let's take an example for a small harvest kind of enterprise. So let's pretend I'm a harvest operators. I'm owning two or three harvester machines and one or two forwarders. Um, so my sensor and controllers are within my harvesters. So they're packed with sensors in the head and the machines, and consuming and providing data with different formats. The SCADA is the onboard computer with, I had a Ponce machine, it would be the Opti 4G software. That's on board the machine, and yet that helps the operator to control his machine, have the interface with different systems. So it's a human machine interface. But if I'm an owner of a few Ponce machines, well, Ponce will provide me if I want the Ponce Manager fleet management software. So it's on my cell phone. I can have an overview of my machines. So in this case, it's more a reporting system, not necessarily a planning system. But for a small company, a small harvest company, that's more than enough. So we've got this that is existing. and probably my wife is making all the accounting for my our family business. So our ERP system is probably QuickBooks on her computer. So you can see that we already have a toe in that system, in that universe. We have just to develop this for develop more of this for the forest operation sector. Um, so that brought us to the idea of right now it's the stage of an idea, and we're trying to scope the project. But the idea of to build a forest operation digital intelligence laboratory. So the idea is to recreate, create a digital twin of an existing forestry business or forestry service within a wood transformation company. Um, with connecting at the top, connecting machines and people that are producing data. So that's the top. We need a communication service. So it's either cell phone or a Starlink or satellite system like Starlink. So this is the communication system, and the data is put into a data trust, a data lake, where all the information, the flow of information is organized in a way we can use it for further usage. With this data, we could make analytics, data fusion, data mining, causal analysis, understanding what's going on, and these tools for analytics, talking about Power BI, for instance, or creating digital twins, or a piece of software called Explore that has been developed by CanMed Energy for massive the analysis of and understanding of massive data cubes. So this is understanding, but um, what we need is to connect this to a manufacturing execution system for forecasting, decision, and monitoring. And there are existing commercial MES. I talked about Ramsoft. There are also other suppliers like Trimble that are producing some. And what we're proposing is to, within this laboratory, to have a place to test them and to learn about them. And CERFO, which is a research and that and technological transfer group at Quebec, could probably do a major role here to support and connect these tools with the laboratory and teach people about how to use it and test the softwares. But also we need to make some research about this and trying to make research with existing software, developing new features. It's not a simple task because of the intellectual property questions. So taking example of a former work done by Forac with timber supply analysis. For instance, they've built their own timber supply model, not to compete with existing solutions, just to help student to understand and student and researcher to understand how things are built and to work on algorithm to improve the processes, improve the model. So this is can be done only with an open access tool, something you can program, can play with. So we're talking about here of developing an open experimental MES to make research, teach, and hopefully me if you was interrupted. Aaron,
Hi, Ron Martin.
have you lost me for a while?
Not very long, just a minute. You can quickly reshare your screen and then, yeah, finish it. For a second, I thought it's my internet. There we go.
So, did you saw this one?
Yep.
Did you saw this slide or
I think you were finished this slide. You were pretty much like wrapping up this slide.
yeah. So um, I'll wrap up my talk. So that is a concept that is still at a really early stage, but we need to scope this and go further for making a real project out of this in collaboration with stakeholders and the Research Institute in Quebec. So what are the next steps? Just to conclude, what's going on here? Okay. So for each project, for the transportation projects, is to complete and test the algorithm with the case study in New Brunswick and be able to measure potential gains by comparing the actual planning with the optimized planning. And for the precision harvest data, we're gonna make the analysis of quality control data to see if we track the quality of data over time. Um, what is the effect of different variables, such as the frequency of the controls and the effect of the operator. And also, we want to model the position of the harvesting head to have a more precise, I would say, hypothesis, or when we're making more precise assumptions where we're calculating the production per hectare. For CTL and hardwoods, we plan to develop and test a bucking algorithm based on LiDAR and to explore, to push the limit about what can be done for bucking with CTL systems, and also the publication of what has been done already, and mapping of digital solution. Well, we're planning to complete data collection and the report within the next 6 months. And the data intelligence lab, well, we're still at early stage, so scoping, planning, and financing the project is part of the plan for the starting year. I want to conclude with my tribute to the Canadian Wood Fibre Center. The Canadian Wood Fibre Center has been the authorities has decided to dissolve the Canadian Wood Fibre Center on March 30 to 31st. So the structure is the structure, I would say, administrative structure of the CIF-IFC is now over, but researchers and professionals are still working under with the same program, with the same directions for on the program side, but with different, let's say, organizations. So I'll be, for my case, for instance, I'll be the managed by the Laurentian Forestry Center. So won't make a lot of change in terms of research or orientation and research work. It will be more organization challenges, but minor. So after 19 years, I've been one of the people from that were founding the Canadian Wood Fibre Center. So I've got my heart is a bit sore about this, but future is bright. So I have to. This was one tribute to the CWFC. So this is a contact, and I'm open to questions.
Thank you, Raman Ching. Before we proceed to the Q&A session, there is a post-webinar for all the participants to fill out, and I'm going to launch it now. And there are 2 questions in total. You may need to scroll down to see the second question. And just a reminder that this session is being recorded and the recording link will be posted on the CIF Open Access e-lecture page.
Hmm.
Well, it seems that there is no question at this moment, but if anyone has any follow-up questions for Ron Martin after this webinar, please feel free to reach out to us and we will help you connect with him. Oh, we have one question for Ron Martin. So thank you for the talk. Is it possible to use data collected at the harvested head to estimate residue biomass that could be collected for another purpose?
Oh, yes. On two sides. First, the wastes, all the parts of the trees that are not merchandised into logs are recorded. So you can record and see what's the potential on that side. With the challenge that it's often more than often very little logs or very pieces. So the operational recovery of this can be challenging. Um, on the other front, Myriam Delmer made her master thesis about using harvester data to calculate what's I would say residues within the top end of the tree. So what are the unmentionable with standards within the current standards? What is the biomass, remaining biomass within the top of the tree? That is possible with the harvester data. In this case, it's not a measurement; it's more an estimation based on calculation.
Thank you, Ron Martin. I think that's all the questions we have for today. If there are no further questions, I would like to bring this session to a close. Thank you all for participating in our CIF electronic lectures. And once again, thank you very much to Ron Martin for the great presentation. I hope you recover from your cold soon.
Thank you very much.
Bye.
Bye bye.